Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you are doing well. Welcome to another video from our chemistry series. This is Mr. Muad and I'm welcoming you again to our channel, Easy Chemistry for All. First of all, thank you for subscribing, and now we reached 284 subscribers. I hope you can still further share the channel with your friends, and also for those of you who did not subscribe yet, please subscribe to help us grow our channel so that the videos can reach more and more students and they can hopefully benefit, inshallah. Thank you very much guys for your support, and let's start bismillah. So we are going to start in module 14, lesson 5 from our Inspired Chemistry series, and we are talking about reaction spontaneity, تلقائية التفاعلات. This is the title of our lesson. Okay guys? Alright, so after this lesson, inshallah, you should be able to differentiate between spontaneous, تلقائي, and non-spontaneous processes. Non-spontaneous طبعا غير تلقائي. And the word differentiate means تفرق, تفريق. You can tell the change, okay? And then we will learn about something totally new called entropy, and you will learn how to predict the sign of entropy. Like, is it positive or negative? The change in entropy, is it going to be positive or negative? Depending on some set of rules. Then we will learn about something called Gibbs free energy, and we'll calculate this type of energy using some values. And finally, we will explain how we can use entropy and free energy to determine if a reaction is spontaneous or not. So how can we know if a reaction is spontaneous or not? We will use the delta S and the delta G to predict that, okay? All right. So before we start, guys, I want you to just try and remember what did we mean by enthalpy change, the delta H, which we covered in lesson 1, lesson 2, lesson 3, lesson 4, okay? Okay, welcome back to the video. So enthalpy is the heat content of a system at a constant pressure. So it's QP, right? Like P is the constant pressure, all right? Now we are interested in the delta H. So the delta H of a reaction, okay, or the enthalpy change or the enthalpy of a reaction is the change in enthalpy during a reaction, and that's delta H Rxn, and we said that Rxn is a reaction, and if the reaction happens at constant pressure, the delta H Rxn can be assumed to be QP, okay? Now when will the reaction be exothermic? Very easy, of course you know, by using the delta H. It's going to be when the delta H is negative. And when will a reaction be endothermic? Endo, inside, absorbing, when delta H is positive. All of this we learned together in the previous videos, right? Okay. Now let's start with stimulating our mind and have a look at this boat, guys. So what's the name of the chemical reaction that happened to this boat? Okay, imagine this is like iron, hadid. طبعا, many of you will say in Arabic, صدأ, right? And some of you will say in English, rusting or rust, right? So this is the reaction. When iron reacts with oxygen, gives me iron oxide. This is the reaction, guys. So it's rust, right? You know about that. We see it a lot, especially next to the sea where the humidity is very high. Now, do you think this rust reaction or rusting of iron happens spontaneously بشكل تلقائي؟ يعني إذا حطينا الحديد جنب المي وخليناه ومر شهر شهرين ثلاثة وجينا, do you think we'll find it rusty or not? I believe all your answers will be yes, right? It will be spontaneous because we can just put the iron there and we will not touch it, and with time it will react with the oxygen in the air and it will produce rust, right? That's what we mean by a spontaneous reaction, guys. Now the main question, are all reactions that release energy spontaneous? So are all reactions that have a negative delta H spontaneous? This is what we are going to discover, guys. So we are focused about spontaneous reactions, and we'll cover these keywords while we are going, okay? Okay. So what's a spontaneous reaction? A spontaneous reaction is a physical or a chemical change that once begun happens with no outside intervention, like what we discussed here. So the formation of rust is a spontaneous reaction. So once it starts, there's no need to do anything. It will keep continuing without any outside intervention, okay? And many spontaneous processes require some energy from the surroundings to start the process. For example, if we turn on the car, once we turn on the car, it will keep working without doing anything, right? So that's an example of the energy at the beginning. Like, this is just an example, okay, guys? So this is the rust reaction, right? It's an exothermic and spontaneous. It's exothermic, why? Because the delta H is negative, right? Now, what is this thing? This is the reverse. هذا التفاعل العكسي, right? This is the reverse reaction. And it is endothermic, right? And it's actually non-spontaneous لأنه عكسه تماما. بما أن هذا exothermic هذا عكسه endothermic. بما أنه هذا spontaneous هذا المفروض لازم يكون non-spontaneous لأنه عكسه تماما. احنا عكسنا المتفاعلات والنواتج, right? So, are all reactions that release energy spontaneous? So this is an exothermic reaction, right? And it's spontaneous. So does that mean that all exothermic reactions are spontaneous? Now, to answer this question, we need to learn about other things other than delta H, okay? And these things will help us answer if a reaction is spontaneous or not, okay? So we will start with entropy, guys, which was one of the keywords. So we need to understand what's entropy, and then we will use it in determining if reactions are spontaneous or not, okay? So what is entropy? So before we go to entropy, just remember that enthalpy, which we covered before, has a symbol of H, and entropy has the symbol S. So entropy is a measure of the number of possible ways that the energy of a system can be distributed. Okay? Now this is related to the freedom of the system's particles to move and the number of ways they can be arranged. So entropy هي قياس للطرق أو عدد الطرق الممكنة للطاقة أن هي تتوزع في السيستم. For example, imagine I have 500 joules of energy, right? And this is my system. So I can have 100 here and 400 in this area. Or I can have 100 here, 100 here, and 300 here. Or I can have 100, 200, 50, 150. But all will amount to 500 joules, right? So the way that energy is distributed in a system, الطرق الممكنة لتوزيع الطاقة في السيستم, we call this entropy. Okay? And it's related to the freedom of the particles to move around and arrange in different ways. Okay? So here's an example. Imagine you have oxygen and helium molecules, right? So there's a molecule of oxygen, there's an atom of helium. In A, this one is closed, and here it's opened, right? So which one has more possible ways to be distributed? What do we mean by that? قصدي إنه أي صورة فيها عدد طرق توزيع الجسيمات أكثر، A ولا B? Of course it's B, right? Because look at this. So the entropy of the system below is greater with the stopcock open. Okay? This is what they mean by this word. So when we open it, look, we can have oxygen here and helium here, or the oxygen can move and the helium can move and they can switch places, or both of them can stay in the same place on the left side, or all of them can stay on the right place. So I have more ways to distribute نوزع الجسيمات. In here I have only one way. In here I have 4 ways. So automatically entropy is bigger here. لأن عندي طرق ممكنة أكثر لتوزيع الجسيمات and their energies. Okay? So this is what we talked about. You can stop the video and read it, guys, okay? Now, in general, the number of possible arrangements اللي هي توزيعات أو ترتيبات available, so the number of possible arrangements available, which is entropy. So if this number increases, entropy will increase. The number of possible arrangements available, entropy, to a system increases under the following conditions. So when does the S increase? Okay? So when the volume increases, because you have larger area for things to move around. When energy increases, that means they will be moving faster and in a random way, the particles I mean. When the number of particles increases, because that increases the possible arrangements available, and when the particles' freedom of movement increases. So if these things happen, إذا هاي الأشياء حدثت, entropy increases. Okay? So for example, this is what we saw in the previous image. إنه الجسيمات صار لها حرية حركة أكثر. اللي هي صورة B. صورة B لما فتحنا الفتحة هاي صار عندها حرية، الجسيمات حرية أكثر إن هي تتحرك، صح؟ That's why the entropy is bigger than here. Okay? So, we are still talking about entropy, but this is just a quick reminder on the law of conservation of energy, the first law of thermodynamics, which we saw in lesson 1 and lesson 2 from the first lessons of this chapter or module. And it tells you that we cannot create energy or destroy it, but we can change it from one form to another. And this is how we can change it from one form to another, guys. And this was the first law of thermodynamics, right? So we already know this. Now, we have the second law of thermodynamics, and the second law of thermodynamics talks about spontaneous reactions and talks about entropy. So what's the second law of thermodynamics, guys? It states that spontaneous processes, العمليات التلقائية, always proceed in such a way that the entropy of the universe increases. So what does that mean? It means, for example, if reaction A is spontaneous, okay? If, for example, we have a reaction A is spontaneous, لو التفاعل A هو عبارة عن عملية تلقائية, so the entropy of the universe will increase. It will go up. Okay, guys? This is the meaning of the second law of thermodynamics. Okay? So, if you are still having doubts or difficulties understanding what's entropy, entropy is randomness. entropy العشوائية. كل ما زادت العشوائية كل ما زادت الانتروبي. اوكي العشوائية في الحركة، العشوائية في عدد الجسيمات، العشوائية في توزيعات الطاقة. اوكي the more randomness you have or disorder, the more the entropy is, okay, or the higher it becomes. So you remember delta H, enthalpy, right? So the enthalpy change was always H products minus H reactants, right, guys? So we are also interested in the change in entropy, the delta S, before reaction, after reaction. Okay, so the delta S of the system equals the entropy of the products, العشوائية حق البرودكتس ناقص العشوائية حق المتفاعلات, the reactants. Okay, and of course the delta S can be positive and negative, right? So if delta S is positive, what does it mean? It means that the entropy of the system, does it increase or decrease? Of course it increases, right? Because the S of the products is higher than the reactants, صح؟ لأنه الأس حق النواتج أعلى من المتفاعلات، لذلك الناتج هنا كان بالموجب، فهذا معناها إنه الانتروبي راح تزداد. Now if delta S is negative معناها إنه الانتروبي of the system decreases because S products is lower than S reactants. Okay? So this is very important to remember, guys. Okay? Now How can we predict the sign of delta S؟ احنا قلنا مرة تكون الدلتا S positive أكبر من زيرو ومرة تكون بالنيجاتيف أقل من زيرو. كيف نتوقع إذا شفنا تفاعل أمامنا قرأنا معادلة كيميائية كيف نقدر نتوقع إذا الدلتا S بتكون positive or negative؟ We have some set of rules, okay? So entropy changes, which is delta S, associated المرتبطة with changes in state مع التغيرات في الحالة الفيزيائية can be predicted. نقدر نتوقعها. شو معنى هذا الشيء؟ Look here. The entropy of the solid, المواد الصلبة, entropy of solid is less than entropy of liquids is less than entropy of gases. كل ما تحولت المادة من الصلب للسائل للغاز كل ما زادت الانتروبي. Okay? When we move from solid to liquid to gas, what happens to the entropy? The entropy increases. Why? Because more freedom of movement or more randomness. العشوائية تزداد لأنه تصير الجسيمات تتحرك بسرعة أكثر تتحرك في بطريقة عشوائية. So for example, if you see a liquid turning into gas, what happens to the delta S of the system? It increases. So it's positive. Right? And from solid to liquid, also it's positive. Okay, what about from gas to liquid? اللي هي عكس هاي. The delta S is going to be less than zero, بتقل. And liquid to solid, the delta S is going to be less than zero. Okay? لأن العشوائية تقل. Now, dissolving a gas in solvent always results in a decrease in entropy. So delta S is less than zero. What does that mean? It means if we put a gas and we dissolve it in water, we take a gas and we put it inside water. So a gas will transform into AQ. You know that AQ from the previous grade, AQ is aqueous. يعني مذاب في الماء. Dissolved in water. So if you see a gas turning into aqueous, the gas particles were moving in a random way, and now we freeze them or we imprison them كأننا نحبسهم داخل المي. So they are not moving freely. ما يتحركون بطريقة ما يتحركون بحرية. That's why the entropy will decrease. So the delta S is going to be less than zero, negative. Okay? Now, the entropy will increase, so the delta S will be greater than zero if the number of gaseous particles اللي هي الجسيمات يعني الجسيمات الغازية in the products is greater than that in the reactants. لو عدد الجسيمات الغازية في النواتج أكبر من المتفاعلات, the delta S will increase. Okay, look at this reaction here. Gas, gas, gas. So we're talking about gaseous particles, right? How many moles here? How many moles are here? So moles. So we have 2 moles here, right? 2. These are the reactants, right? And these are the products. So هاي المتفاعل. The products عندي 2 moles here of SO2 and we have 1 mole here. So in total we have 3. In total we have 2. So the moles in the products, عدد المولات الغازية في البرودكتس في النواتج أكبر من عدد المولات الغازية في المتفاعلات. Remember, I'm talking only about gas. Solid, liquid, aqueous, we don't count them. ما نحسب السوليد والliquid والaqueous. Okay? So because this happens, the delta S is going to be positive and the entropy increases. Okay, guys? All right. What's condition number 4? With some exceptions, entropy increases when a solid or liquid dissolves in a solvent. Okay? So the delta S is going to be greater than 0. When we dissolve a solid, so for example, a solid goes into aqueous or a liquid goes into aqueous, هذه عليها بعض الاستثناءات بعض المرات, but usually the delta S will increase. Why? Imagine you put salt. This is salt, right? Look at salt. The particles are all connected with ionic bonds. الأيونات كلها مرتبطة مع بعض بالروابط الأيونية ما تتحرك. لما نذوبها في المي الأيونات تنفصل عن بعض، الأيونات الموجبة والسالبة تنفصل. The positive and negative ions will dissociate, right? They will move apart from each other and they will move freely. That's why when a solid turns into AQ, the delta S of the system will increase. Why? Because now they are moving freely. يتحركون بحرية الأيونات. Okay? لما كانوا في الحالة الصلبة في الملح, when they were in the solid state in the salt, they were not moving freely, right? So that's why when we put them in water, they will dissolve. They will dissolve, and then the delta S of the system actually increases. Okay, guys? And finally, the random motion of particles of a substance increases as its temperature increases. So, if we increase the temperature, the delta S is going to be greater than 0 because the particles are moving faster and faster. And that's why the entropy increases when the temperature increases. This is the easiest one. Okay, guys? So, you can repeat this video. You can increase the speed if you think it's slow. So, it's up to you. And then now let's go and try to solve some practice problems, okay? Based on these rules, the 5 rules, 1, 2, 3, 4, 5. Predict, توقع the sign of the delta S of the system for each of the following changes. So you can stop the video here, try to solve it on your own, and then come back. Okay, guys, thank you for your effort. Thank you for trying to solve this part. Now let's do it together and check if your solutions are correct. Let's start with A. You have a reaction where you have two reactants and one product, and all of them are gases. So when you see this, you think about which rule? About rule 3, which talks about gaseous particles, right? So let's count. Here we have 1 mole, and here 1 mole, and here 1 mole of gas particles, right? So in here we have a total of 2, and here we have a total of 1. So what happened to the number of moles? They decreased, right? So the number of moles decreased. So what should happen to the delta S? It should be less than 0 because the number of moles of gases decreased. احنا كنا قلنا في rule number 3 إذا المولز زادت الانتروبي تزيد. الحين صار العكس. Now the opposite happened. The moles decreased in the products, so the delta S is going to be negative, less than 0. Gas becomes aqueous. This was number 2. When gas becomes aqueous, the delta S of the system is negative. Okay? So, the delta S is less than 0. Negative. What about here? Liquid becomes solid. We saw it in rule number 1. When a liquid becomes a solid, the delta S becomes negative, guys, right? So the delta S is negative because the movement becomes restricted. Okay, challenge. Comment on the sign of delta S system for the following reaction. Okay, so 1 mole, 1 mole, 1 mole, mole. Now this one turns into aqueous. So the delta S here becomes positive, right? Because we said if you go from solid to aqueous, the delta S becomes positive. And this one was aqueous and becomes solid. So the delta S decreased. So increased and decreased. What do you think the total delta S should become? It should become 0, guys. ليش؟ لأن هني الدلتا S كانت بالبوزيتيف وهني كانت بالنيجاتيف. هني الانتروبي ارتفعت وهني انخفضت. فالتأثير الكلي 0. So the total change should be 0. Okay? Or close to 0. Alright, guys? Because it increased once and it decreased again. So that's why the total change should be 0. Okay, that was for the part of entropy, guys. Hopefully you understood how you can predict the signs using these 5 laws that we covered, okay? And these are the rules that we talked about. You can read them here from the slides, okay? Now we go and talk about some other things. Okay, still talking about entropy. We'll give some definitions and some points, and then we'll move to free energy. Okay, so remember that universe from lesson 2, universe is equal to system plus surroundings. صح؟ تكلمنا عليها in lesson 2. So the delta S of the universe, the total delta S of the universe, is the delta S of the system, which we have been talking about now or previously, plus the delta S of the surroundings. Okay, guys? So the delta S of the universe tends to be positive. يعني delta S universe تكون أكبر من 0, bigger than 0, if the reaction or process is exothermic. So when the delta H is exothermic, less than 0. This raises the temperature of the surrounding, so the delta S is positive. Okay, guys? The entropy of the system increases, so the delta S of the system is positive. Thus, exothermic chemical reactions accompanied by an increase in entropy are all spontaneous. What does this mean? It means if a reaction is what? If a reaction is exothermic, okay, يعني delta H less than 0, and the delta S is bigger than 0, يعني الentropy is up. If these things happen, then the delta S of the universe increases, meaning it's positive, and that means the reaction is spontaneous. So if you remember the second law of thermodynamics, which we saw previously here, it says that spontaneous processes اللي هي العمليات التلقائية التفاعلات التلقائية تكون دائما الانتروبي of the universe, the delta S of the universe increases, يعني positive, يعني delta S of the universe is positive, and that's what we saw here. So using the second law of thermodynamics, if a reaction is exothermic and the entropy of the system increases, then the delta S universe increases, and that means it's spontaneous using the second law of thermodynamics. But how can we know this? How can we know if it's in exothermic or if the delta S is positive? How can we know if it's spontaneous just like that? Okay, so how can we determine if a reaction is spontaneous or non-spontaneous? Okay, by calculation, for example. So we need the delta H, we need delta S, and we need something that we will study now, which is called Gibbs free energy, the delta G. And now, guys, the full picture will come to you, because at the beginning of this lesson, we are trying to answer this question, right? When can we know if a reaction is spontaneous or non-spontaneous? So now you will see the full picture in a bit. So what do we mean by free energy? For reactions or processes that take place at constant pressure and temperature, free energy is the energy that is available to do work. Okay? So any available energy in a system which can be used is called free energy. It's free. We didn't use it yet. Okay? And it's actually called Gibbs free energy of the system. I think Gibbs is the scientist who named this type of energy. Okay? So this is the definition of free energy. هي الطاقة المتاحة لعمل الشغل. Okay? Now, we have this famous equation which is very important. Okay? This is super important, guys. Because this is the one that will tell you if a reaction is spontaneous or non-spontaneous. Okay? So this is called Gibbs free energy equation. It tells you the delta G of the system equals the delta H of the system. We know this, minus T, the temperature, okay, times delta S of the system. We know delta G is the free energy change, delta H is the enthalpy change, T here is temperature وهني temperature مضروبة ضرب الدلتا S اللي هي change in entropy. Okay? Now, when a reaction happens under standard conditions, remember standard conditions? Remember delta H and we have a small degree here. It means it's standard conditions. يعني temperature equals 25 degrees Celsius and the pressure equals 1 atm. So لو التفاعل تبعنا موجود أو حدث في الحالة القياسية in the standard conditions, then we can represent the equation using this degree, guys. Okay? Very, very important. Now, delta G will tell us if a reaction is spontaneous or non-spontaneous. العلامة تبعت الدلتا جي هي اللي راح تقول لنا إذا التفاعل تلقائي أو غير تلقائي. If the sign of the delta G is negative, so if delta G is less than 0, the reaction is spontaneous. So delta G less than 0, spontaneous. If the free energy is positive, the reaction is non-spontaneous. If delta G is bigger than 0, it is non-spontaneous. So here it's negative, here it's positive. So the sign of delta G depends on the delta H, delta S, and the T, right? Also, this table is very important. هذه التable or this table explains when the delta G is negative and when it is positive, depending on the delta H and the delta S. The easiest part is row number 1 and row number 4. Okay? So, if delta H of the system is negative, meaning it's an exothermic reaction, and the delta S is positive, then the delta G is always negative. Okay, guys? Why? It's just in the equation. Imagine that delta H equals minus 10 kilojoule, and the delta H equals what can I say? Positive 3, for example. So if you do minus 10 using this equation here, if you do minus 10, so the delta G is delta H minus 10 minus the temperature, whatever it is, right? Times 3. So minus and minus, okay? Minus, the answer should be in the minus, right? لأنه ناقص, the answer should be in minus. I'm not multiplying, إحنا ما نضرب. We are adding minus plus minus, okay? So the delta G is always going to be negative, and that's why the reaction is always going to be spontaneous. Now, if the delta H is endothermic and the delta S is negative, the delta G will always be positive, and it's never spontaneous, non-spontaneous. Okay? So for example, minus 10 minus T times, plus 10 minus T times minus 3. The delta H is positive and the delta S is negative. Minus with minus becomes positive, so this becomes 10 plus 3T, whatever the temperature is. So the answer will be in positive, and that's why the delta G is going to be positive and never spontaneous. Now the problem is when both have the same signs. When delta H and delta S, both of them have the same signs. إذا الدلتا H والدلتا S اثنيناتهم عندهم نفس الإشارة. اثنيناتهم negative واثنيناتهم positive. So if both are negative, the delta G can be negative or positive. Who will determine the temperature T اللي ما تكلمنا عليها؟ يعني لما الدلتا H والدلتا S يكون عندهم نفس الإشارات، اللي حيحدد إشارة الدلتا G هي التمبريتشر. So when delta H or delta S have the same signs, the one that will decide if the delta G is positive or negative is the temperature. So at lower temperatures, the reaction will be spontaneous and delta G is negative. At higher temperatures, the reaction is going to be spontaneous and the delta G is negative. Okay, guys? You will see this in an example, all right? So we are going to use this table in an example to help us calculate the delta G. But you need to remember these conditions. هاي الconditions أو هاي الحالات لازم نتذكرها لأنه يجيبها اختيارات مرات في الامتحان النهائي. All right. So now, guys, let's go ahead and read this problem, okay? And try to answer. So they are asking you or telling you for a process, delta H of the system equals 145 kilojoule, okay? And delta S of the system equals 322 joule per Kelvin. Is the process spontaneous at 382 Kelvin? So, what did they give us? Known or given, المعطى, delta H equals positive 145 kilojoule. Guys, you need to focus on the units. لازم نركز على الunits, okay? The delta S equals 322 joule per Kelvin, and the temperature equals 382 Kelvin. قياس التمبريتشر هني بالكلفن، okay? unknown spontaneous or non-spontaneous. هذا التفاعل اللي عنده هاي القيم, the reaction that has these numbers, is it going to be spontaneous or non-spontaneous? So in other words, they are asking you about delta G. They want you to find delta G. Because you know, if delta G is positive, non-spontaneous. If delta G is negative, it is spontaneous. So write the equation of delta G. Delta G equals delta H minus T times delta S. Guys, before you put the numbers in the equation, you need to focus on the units. You need to make the units of delta H and delta S the same in terms of joule. يعني لو هذه كيلو جول وهاي جول لازم تخليهم نفس الشيء. Because you're adding, because we are adding or subtracting. So you need to make them the same. So this one is in kilojoule minus, now T times delta S, when you multiply T times delta S, the unit of T is Kelvin and delta S has joule per Kelvin, right? So this will go with this one, so you will stay with joules. So all of this will have the unit of joules. Can we do kilojoule minus joule? We cannot. They have to be the same. So we either change this into 145,000 joules, نحول من الكيلوجول للجول. So we go from kilojoule to joule, we multiply by 1000. Or نحول الدلتا S, so from joule to kilojoule, you divide by 1000. For me, I will choose this one because it's easier. I will just multiply by 1000. So I need to put these numbers. So delta G equals 145,000 joule minus, what's the temperature? 382 Kelvin times 322 joules per Kelvin. So the Kelvin will go with the Kelvin, and now I have the joules. Now you just multiply and check your answer. So it's equal to 145,000. Okay, sorry. The final answer is going to be 21. Okay, 996. So positive 2196 joules. Okay, remember this is energy. So it should have the unit of joules because both of these are joules. So the delta G is actually positive. So delta G is greater than 0. So do you think it's spontaneous or non-spontaneous? What do you think, guys? It's actually non-spontaneous. Okay, it's going to be non-spontaneous. Why? Because the sign of the delta G is actually negative. Tamam? That's it. So this is how we know if a reaction is spontaneous or not. So now we reached the end of the explanation. Now let's check your understanding. So what is not true? What is not a true spontaneous process? أي مما يلي ليس حقيقي أو صح بالنسبة spontaneous process. It applies to both physical and chemical changes. This is true. It occurs without outside intervention. This is also true. Rust is an example. This is also true. Energy from the surrounding must always be supplied to get the process started. Well, it's not must always, okay? It's not must always. So if they say usually, okay, but must always is a strong word. So you don't always need this type of energy at the beginning. Okay, that's why D is the correct answer. What is the symbol of entropy? So entropy is actually S, right? What is H? H is enthalpy. G is free energy. And E, this is the electrical field in physics, okay? We did not study anything about E here, or we'll cover it actually in the next, in term 3, inshallah. Or in term 2, inshallah, when we talk about electrochemical cells, okay? Under which of the following conditions does entropy decrease? So delta S less than 0. When the volume increases? No. When the energy increases? No. Both of these will increase entropy. The particle freedom of movement increases? No. The number of particles in the system decreases. That's our correct answer. Because all of these will increase the entropy, and we talked about it in the slides if you go back. Second law of thermodynamics states that spontaneous processes always proceed in such a way that the entropy of the universe, remember this, we saw it twice or 3 times. So both of these are wrong. Remove the wrong answers. So it's either decrease or increase. So it always proceeds in a way where the entropy of the universe increases, guys. Okay? That was the second law of thermodynamics. Finally, what is true of free energy? It is the energy of the random motion of particles. It is the energy that exists outside of a chemical system. It's energy that is available for work. If free energy change is positive, the reaction is spontaneous. So remove the wrong answers. This is wrong. If it's positive, the reaction will be non-spontaneous, صح? Now, this thing has nothing to do with it. Random motion of particles. So when we talk about motion, we're talking about kinetic energy, right? So actually, it's the energy available to do work. And we saw this in the definition, okay? Excuse me. Alright, guys, so we reached the end of the lesson, okay? That was the end, sorry. That was the end of the lesson, guys. Thank you for watching the video. Again, please, if you did not subscribe, please subscribe to the video, guys. Let's reach 1,000 subscriber with your help. Try to share the channel with your friends, with your colleagues, with your classmates, and hopefully, I hope they can benefit from these videos. This is Mr. Muad. Thank you for listening, and see you inshallah in the next video, guys. Take care.